Hi, welcome to Back Alley Chemistry. Last week we made camphor in the lab, and this week we're going to use a reduction mechanism to reduce camphor to boronil and isoboronil. We're going to use sodium borohydride, which produces 4 moles of an H- to attack and replace the carbonyl carbon, as you'll see in this mechanism. Oh, hello there. Why don't you follow us back to our back alley whiteboard? Hey, come on over. Come on. Come here. This is a reduction of a carbonyl using sodium borohydride. As you can see, the partially positive charged carbon here is double bonded to an oxygen. This allows the electrons from the double bond to move onto the oxygen, and the hydrogen may push off the sodium borohydride onto that structure. In the presence of an acid, represented by this H+ here, we can see that the double bond, the 2 free electrons now on this oxygen pick up that hydrogen, making our resulting product.
And as a result, our mechanism produces a primary alcohol. However, in our case in lab, we're going to produce a secondary alcohol, which will be boronil and isoboronil.
This has been another episode of
Back Alley Chemistry.